Hi, today we're going to look at triangle congruence. Two figures are congruent if all of their measures are congruent. So think about how many things there are to measure on a triangle. A lot of times if I ask you, how many things are there to measure on a triangle? A lot of us will answer 2, angles and sides. Okay? Or we'll say 3 because there's 3 sides. Or we'll say 3 because there's 3 angles. But really there are 6 measurements that you can take on any triangle because you can measure 3 angles and you can measure 3 sides, totaling 6 measurements. To show that 2 triangles are congruent, you have to show that all 6 measurements from one triangle are the same as all 6 measurements on the other triangle to say that they are congruent. So if we want to show that these 2 triangles are congruent, we'll list all the congruent angles and sides of these 2 triangles. So I can tell by the single arc mark that angle A is congruent to angle R. I can tell by the double arc marks that angle B is congruent to angle S. And I can tell that angle C with the 3 arcs is congruent to angle T with the 3 marks. Then we'll do the same thing with the sides. So if I look, I have a single tick mark. I can call this either segment AB or segment BA, either one. Since it has a single tick mark, that segment is going to have the equal measure or be congruent to segment RS or SR. Okay? Then if I look at my side that has the 2 tick marks, AC or CA, will be congruent to, so I had 2 tick marks, here's 2 tick marks, so either RT or TR, you can say it either way. And then last but not least, my 3 tick marks, I have BC or CB, you can write it either way, is congruent to segment ST or TS. You can write it either way. But I have 6 total sets of congruent parts. Okay? When you can show that 2 triangles or 2 figures are congruent, then you can write what is called a congruence statement. And that's a statement that says the 2 triangles or 2 figures are congruent, and at the same time it tells me which angles and which sides are the corresponding congruent parts. Okay? So, for example, if I want to write a congruent statement, the first thing I'd have to do when naming a triangle is I have to use a triangle symbol. So I have to see that. If I don't see that symbol, then I'm not naming a triangle, I'm just listing 3 points. Okay? So then I look at one of my triangles. It doesn't matter which one I put first. Let's say I go with this one. And then I get to pick what order I want to name its corners in. So I can do them alphabetical, A, B, C, or I can try to spell something, C, A, B. It doesn't matter how I do it. Okay, so the first one, I'm just going to go alphabetical, A, B, C. They're coming from points, so they do have to be capital letters. Okay, and we're going to say that it is congruent to. And we're going to say it's congruent to another triangle, so I have to use my triangle symbol. Now, remember, we said this has to show which angles and sides are corresponding congruent parts. So I need to match up A with what it's corresponding and congruent to. So I know that angle A matched with angle R. So if I start here with A, then I have to go to R. Okay? Then my second letter is B, and I know that B matched with S. And then my last letter is my last letter is C with the 3 arcs, and I know that C matched with T. Okay, so even if I didn't have my picture, I could look here and I know that angle A matches with angle R and they're congruent. Angle B is congruent to angle S, angle C is congruent to angle T, even if I didn't have a picture. Notice it also says I can tell which sides are corresponding and congruent, and that's by looking at the letters next to each other. A and B are the first 2 letters, so I know they match with R and S. So AB is congruent to RS. AB is congruent to RS. Then look at the second two letters. BC is congruent to ST. BC is congruent to ST. To get this middle one, look at the outside letters, AC and RT. AC is congruent to RT. So even if I don't have any of this picture, if I have this congruent statement, I'll know what is congruent to which parts. Okay? Because we use the congruent statement to be able to see what is corresponding and therefore what is congruent, we need to make sure that we know that order is important. So anytime from here on out I go, what's important? Your answer for the rest of the year should be order. Order is important. Okay? All right, so let's look at these examples and see if we can write congruence statements. Remember, we need to be able to show that everything, all 6 pieces, are congruent. So let's see. When I look at this first example, can I show my 3 angles are all congruent? So A is congruent to J, B is congruent to K, C is congruent to L. Yes. AB is congruent to JK, BC is congruent to KL, and AC is congruent to JL. So yes, I can write a congruent statement. Triangle, and again, you can pick your letters for the first one. Let's spell CAB, CAB. Triangle CAB is congruent to triangle. So if I started at C, I've got 3 arc marks. So 3 arc marks, I go to L. And then from C, I went to A. So I went across 3 tick marks to a single arc mark. So I'm going to go across 3 tick marks to a single arc mark J. And then I end up at B, across the single to the double, across the single to the double, K. Triangle CAB is congruent to triangle LJK. Again, super important that you have your triangle symbols in front of each triangle, that your letters are all capitalized, and that they're in the correct order. Okay, let's look at the next one. On the next one, I do see that I have 3 congruent sides, a single, a double, and a triple tick mark. And I have a right angle here and a right angle here. Okay, but I don't have any information about these 2 angles, and I don't have anything about these 2 angles. So for the information we have as of today, we are not going to be writing a congruent statement for this one because I'm only showing 1, 2, 3 sides and 1 angle. So I only have 4 things marked congruent in my picture. So I'm going to write, for today, it's not possible. Okay? All right, let's look at the next one. All right, for this one here, when I look at my left triangle and my right triangle, my left triangle, I have a single that matches with a single. I have a double that matches with a double, and a triple that matches with a triple. So we're good on our angles. And then our sides, single, single, double, double, triple matches with itself, the triple. So all my sides have a matching part in each triangle, and all my angles have a matching part in each triangle. So we can say that yes, these triangles are congruent. Again, I can name the first one anything I want. I'm going to go back to alphabetical. ABC is congruent to triangle. I started at A, that's my single arc, so I start at D. From A, I went to B, so I went across the double up to B. So from D, I'm going to go across the double down to C. And then A, B, C, A, B, C. Now I'm going to go D, C, up to B. Okay? There are my congruent triangles. All right. When I look at this last example right here on this page, I can see that I have 3 angles that match. A matches with D. This B, I can't really call this one B because it's got 3 angles here, right? The one with 2 arcs, the one with 3 arcs, and the whole thing. So this one I really should call it AB, angle ABC, right? Because this side is angle DBC. So angle ABC matches with this side, angle DCB. So those 2 angles match. And then angle DBC, this side, matches with ACB, this side. So I do have 3 sets of angles, so I have 3 sets of sides. I have a single tick mark here and a single tick mark here, so these 2 sides match. A double here and a double here, so these 2 sides match. And then BC doesn't have anything on it. But this we call, when they share a side, we call this the reflexive property of equality. And what that states is it states you're allowed to say that BC, segment BC, is congruent to itself, segment BC. Which means I can say it equals itself. I can put those, I'm allowed to add those tick marks on there. Okay? So since I'm allowed to use the reflexive property and say that this segment does equal itself, I can say these triangles are congruent. Okay? So if I name my first triangle, let's go BAC. Angle B, or triangle BAC, is going to be congruent to triangle. If I started here at B, my double, then I'm going to start here at C. Then from B I went to A, so I went across the single out to A. So from C I'm going to go across the single out to D, and then end up at B. Okay? Triangle BAC is congruent to triangle CDB. Okay? And again, you could get different answers for this, because this first one, if I change this to ABC, then this one would be DCB. The second one will always be dependent on what you choose for the first one. Okay? Now, I do have a question to ask though. It says, if you chose not possible, does it mean those 2 triangles are not congruent? Does it mean that these 2 triangles are not congruent? Could they be congruent? Could this angle be the same as this one? Yes. Could this angle be the same as this one? Yes. So just because we said it's not possible doesn't mean they're not congruent. Okay? So we're going to say no. We just don't have enough information. So they might be congruent, we just don't have enough information to say for sure that they're congruent. Okay? All right, the next video we're going to go ahead and start looking at some examples of how we use congruence statements to help us in finding missing values of congruent triangles. All right, thank you so much for watching.